All right, let's talk about one of Python's most powerful and honestly most used data structures, the dictionary. By the time we're done here, you'll know exactly how to use them to organize your data like a pro. And hey, if you want more deep dives like this one, make sure you subscribe to this channel. Okay, let's get into it.
You know, the best way to wrap your head around a Python dictionary is to just think of a real one. You know, the paper kind. You look up a word, that's your key, and it points you to a definition, that's your value. Well, Python dictionaries do the exact same thing. You give it a unique key, and it instantly gives you back the value that goes with it. It's a really simple idea, but oh man, is it powerful.
So there are 4 things you absolutely have to know about how these work. First, everything, and I mean everything, is stored in these key value pairs. Second, and this is a newer thing, as of Python 3.7, they actually remember the order you put things in. Super handy. Third, they're mutable, which is just a fancy way of saying you can change them on the fly. Add stuff, remove stuff, change values, whatever you need. And last, but this is the big one, keys have to be unique. No duplicates allowed.
And here's what one actually looks like in your code. We've got a dictionary here called student. The keys are the strings name, age, and course. And the values are dev, the number 20, and the string Python. See how it just neatly bundles all that related info together? That right there is their superpower. Okay, so you get the concept. Now let's get our hands dirty and build out our toolkit. We're going to look at how to actually create these things and then manage all the data you put inside them. This is the practical stuff you'll be using day in and day out. So, you've got 3 main ways to kick things off. The one you'll see most often is the basic method, just using those curly braces. You can also just create an empty dictionary and then add to it as you go, which is incredibly useful. And finally, you can use the dict constructor. They all get you to the same end result, so you just pick whichever one feels right for what you're doing. Okay, pay attention here, because this is a big one. To get a value out, you can just use square brackets with the key. It's fast, it's direct, but, and this is a big but, what if that key isn't in there? Boom! Your whole program crashes with an error. That's exactly why the .get method is your best friend. If the key is missing, it doesn't crash, it just calmly returns none. So here's the takeaway. When you're not 100% sure a key exists, use .get. It'll save you a lot of headaches.
Now this is just beautiful, elegant design from Python. Adding a new item and updating an old one, you use the exact same syntax. The only thing that matters is the context. If you give a value to a key that isn't there yet, like city here, Python just adds it. If the key, like age, is already there, Python just updates the value. So simple, so smart.
And what about getting rid of things? Well, you've got options there too. Pop lets you remove a specific item using its key. Pop item is great for when you just want to take off the last thing you added. The del keyword also zaps a specific key. And if you want to just wipe the whole thing clean without getting rid of the dictionary itself, .clear is what you want.
All right, you've totally got the basics of handling individual items now. So let's talk power moves. Let's see how you can work with the entire collection of data inside your dictionary to do some really cool and useful stuff.
You know, sometimes you don't want just one piece of data, you want a whole bunch of it. Well, .keys gives you a list of all the keys. Simple enough. .values gives you all the values. And the real powerhouse of the 3, .items, gives you everything. All the key value pairs all bundled up and ready for you to work with. And that leads us right into looping. Now, if you just loop over the dictionary itself, Python will hand you the keys, one by one. But the pattern you're going to see everywhere, the one you'll probably use 99% of the time, is looping over .items. This is awesome because it lets you grab both the key and the value at the same time in each go-around of the loop. Super, super useful. Okay, let's just quickly recap the golden rules. Keys are unique, the dictionary is changeable, and lookups are ridiculously fast. Now for the big don'ts. The keys themselves have to be immutable, which means they can't change. That's why you can use a string or a number as a key, but you can never, ever use a list. I mean, think about it. If the key could change, how would the dictionary ever find it again? It'd be like your house constantly changing its address. This rule is what makes dictionaries so fast and reliable.
So, we got all the theory down, but why does any of this actually matter? Let's connect all these ideas to the real world and see where dictionaries are the absolute star of the show.
The short answer is, dictionaries are literally everywhere. If you're doing web development, they're the heart of JSON data and APIs. In data science, you're using them constantly to organize complex information. They're critical for automation scripts, for storing configurations. Pretty much any time you have structured data in Python, you're going to be reaching for a dictionary. Okay, time to put what we've learned to the test. Here's a classic programming problem. Count how many times each word shows up in a sentence. This problem is practically begging to be solved with a dictionary. And the logic is just so clean. First, we start with an empty dictionary to hold our counts. Then we loop through each word. And for every single word, we use our safe little .get method. We ask the dictionary, hey, what's the current count for this word? If it's a new word we haven't seen before, .get just gives us back our default, which is 0. Then we just add 1 to whatever number we got back and save it.
And bam, there's the result. After our loop runs through apple, banana, apple, our dictionary perfectly stores the final counts. The key apple has the value 2, the key banana has the value 1. And just like that, in a few simple lines of code, we've solved the problem. So elegant.
So there you have it. That's your crash course in Python dictionaries. They're not just another data type. They are your go-to tool for organizing related information. So the real question isn't what they can do. It's now that you have this tool, what data in your world are you going to organize first?